Hi. Okay, so I'm Emily. I'm a tutor at the Math Zone, and I'm just going to go through how to find the zeros of a polynomial. Apologies if there's a delay in the camera going through two devices here. Um, okay, so first I'm going to go through a couple learning objectives. You're gonna by the end of this, you're going to be able to know the difference between zeros and possible zeros. You're going to review the quadratic function and synthetic division as well as factoring, and you're going to be able to find imaginary roots. So just a couple definitions to start. Your zeros in general are just points where the function's value or x is zero, or when the function crosses the x-axis. So in the picture that I have there, you have two zeros at -2 and 2, because that's where the function crosses the x-axis. And then another term is imaginary roots. Technically, it's the discriminant value, a discriminant value that's less than zero, also known as complex numbers. In an equation, this is when an I is present, or on a graph, it's when the zeros do not cross the x-axis. So in the picture there, the first graph shows a couple of imaginary roots because the function doesn't cross the x-axis. And then the last thing that we're going to come across is the highest degree. This is just the highest power of a variable in a polynomial. So it's just going to be basically our highest degree in a polynomial. So in green, a very bright fluorescent green, we have a couple different examples of different polynomials. I'm just going to skip down to the third one. There is our highest degree is 2. That means the highest degree of the function or the polynomial is 2, and so on and so forth. So I just kind of put in like a little step-by-step process to find zeros, and I put in bold the most important parts of each step. So first, you're going to use the P over Q method to find all the possible zeros. This is also known as the rational zeros theorem. And the next step is to enter all of your possible zeros into Desmos, only the scientific calculator, until you find one that equals 0, in which case we can proceed with step 3, where we're going to use synthetic division to divide the initial expression by the found 0. And then you're going to lastly factor the remaining equation with the quadratic formula. You can also check your work if you want. Your number of zeros should correspond with your highest degree. So if your highest degree is 3, you should have 3 zeros. If it's 2, you should have 2 zeros, etc. And then I just have a couple of examples to go through with you guys to make sure you have a good understanding. So this one's the easier one, I guess. And here is our equation right in the middle. So we're going to start by, if we go back to our step-by-step, we're going to use the P over Q method to find all the possible zeros. So our P is our number on the end that does not have a variable, and our Q is whatever our leading term is. So when we don't have a number, that's an imaginary 1. So our Q is 1. P over Q is just like how it sounds, P over Q, or P is -4 over Q, which is 1. Then we are going to take all of our, all the numbers that can multiply to each of our P and Q, and list them out. So ignoring the negative sign, we have 1, 2, and 4. And then for 1, it's just 1. And then it's going to be the positive and negative versions of each. So that's why we're ignoring the negative, because we're taking into account the positive and negatives anyway. So now, and then just like how it says P over Q, we divide. So all of our possible zeros are going to be 1 over 1, or 1, 2 over 1, or 2, and 4 over 1, or 4. And again, the positive negatives of all of those. And then now that we have 1, 2, and 4, we're going to go to Desmos and take our equation and we're going to put x squared. Where is our x? X squared plus 3x minus 4. So that's going to be 3x minus 4. And then we're just going to do x equals there we go. 1. So since you can see on the top equation there equals 0, that means it will be a actual 0. Again, the difference, or not again, but the difference between possible zeros and zeros, possible zeros could be any number that you find after the P over Q method, and then your zeros are only the numbers that end up equaling 0 once you complete the P over Q method. So once we find 1, we can proceed with that 1. So positive 1 works. So now we're going to move on, and our next step is to use synthetic division. So 1, synthetic division, I'm going to put our 1 on the outside, and then I'm going to take each of the numbers, leading each of our variables, and put them next. So we have 1, 3, and -4. And then this is just regular synthetic division. I bring down my first number, I multiply 1 by that number, and I get 1. And then I add, and I get 4. 1 times 4 is 4. And then I add, and I get 0. And then I'm going to rewrite this as 1x plus 4, or just x plus 4. And that is our equation. And then we're going to take that through the quadratic formula. So I'm going to put up here quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac. What is AC? All over 2a. So taking what we have here, if we don't have any x squared plus x plus 4. Jesus. So, or actually, we don't even have to go that far. I'm going to save the quadratic formula for my second example. X plus 4, we just set that equal to 0. And we get x equals -4. So our two zeros are going to be +1 and -4. And if I put that back into the equation like I did with the 1, if I put -4, as you can see, it works. So that's our final answer. And we have 2 zeros, which correspond to the highest degree of 2. So that is our first example. And here is the second example, which is a bit more complicated. We're just going to go through the same steps, starting with the P over Q method, where -100 is our P. That imaginary 1 is our Q. And it's going to be P over Q. Again, I'm going to ignore the negative because we're going to take into account all of our negatives and positives anyway. 100 over 1, and then everything that multiplies to 100. That's a lot of numbers, but we'll get through it. We got 1, 2, 4, 5, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 25, 50, and 100. All over 1 is our only one for Q. And then just like before, I'm going to divide. So all of our possible zeros are going to be 1, 2, 4, 5, 10, 20, 25, 50, and 100. And again, all positives and negatives of each. The next step is to enter our possible, or first put the equation. So x cubed minus 4x squared. I'm going to just delete our last one. X cubed minus 4x squared. Plus 25x minus 100. And now that we have that equation, I'm just going to enter each of my possible zeros and see which one equals 0 at the top. So this one does not work because our remainder is negative 78, or the equation equals negative 78. We're looking for when it equals 0. So I'll try -1. That doesn't work. 2, -2, 4, 4 works. So now we're going to go ahead with 4. So I'm just going to put a little check mark, positive 4 over here in the corner. And then we're going to take that number and run it through synthetic division. So up here in the top corner, I'm going to put 4 and then each of my leading numbers. So 1, -4, 25, and -100. I'm going to bring the 1 down, multiply my 4 by 1, and get 4. Get 0. 4 times 0 is 0. Add those, get 25. 4 times 25 is 100. Add those, and get a remainder of 0. This is going to be rewritten as 1x squared plus 0x plus 25. And then I'm going to take this and put it through my quadratic formula. X equals -b plus or minus the square root b squared minus 4ac all over 2a. If 1 is my a, 0 is my b, and 25 is my c, I'm just going to take each of my numbers and put it in the placeholder variable. So x equals -0, or just 0, plus or minus the square root of b squared, which again is just 0, minus 4 times a, which is 1, times c, which is 25, all over 2 times a, which is 1. This simplifies to x equals the square root of -25, or -100, sorry, -100 over 2. So this is when we encounter an imaginary number, because you can't have the square root of a negative number. That's not possible. So to get around that, we're going to put an I in front of our square root and then solve it as if that square root wasn't there. So I just got rid of the negative and put an I in front of the square root. And then you can simplify the square root of 100 into 10 and 10, which the square root of 100 is just 10. So it's going to be 10i over 2. I'm sorry, this is messy. Okay. Again, I forgot, but you're going to put plus or minus in front because it could be either. So plus or minus 10i over the square root of 2. This simplifies to plus or minus 5i. And that's as far as we can go. That's completely simplified. So then if we take into account our positive 4 from the start and our two numbers, positive and negative 5i, that gives us 3 zeros. So zeros 4, negative 5i, and positive 5i. That's 3 zeros, which corresponds with our highest degree of 3, meaning that is our final answer for all of our zeros. All right, that is all I've got today. If you have any questions or you want extra help, the Math Zone is always open, and we have a lot of tutors that would love to help you guys out. So, yep, thank you for watching, and good luck.